for this PowerPoint, we're not gonna, like I said, you don't have to write everything down. The case study for it, actually pretty interesting. When we watched the Story of Stuff cartoon, at the beginning of the semester, it had the lady that made you think, you know, you were gonna die, and she was like, I went to Radio Shack and I got this radio for $4.99, and then she was talking about externalized costs, and you don't have this PowerPoint. Like, don't look for it. You don't have it. I'm not making you write it down. We don't need to waste paper on it. But the coltan she was talking about in that radio is actually mined out of the Democratic Republic of Congo, and they're definitely, you know, have issues with civil war, and most of the people that mine out the coltan are children, and they don't get to go to school, and the profits for this mineral go into war. They fund war. And this is the stuff that's inside of your iPhone. And so the rainforest was cleared out. People entered the national parks. Profits for, like I said, the coltan went into financing war. And so, like I know Apple has tried to do better with getting these minerals. So there's the Democratic Republic of Congo, and there's where they mine out coltan. So rock, yeah, is an aggregation or a collection of minerals. And a mineral is kind of what we're talking about. So on number 6, 10 minerals that you use around your home and how you use them. Here's your opportunity to get those down if you didn't yesterday. If you did get them down, then okay, good for you. But we have aluminum in the cans, gypsum in wallboard. Like if you've ever had like a hole in your wall, or you've ever like took a nail and tried to hang up a picture, and then white powder comes out of your wall, that's gypsum. That's the stuff inside of sheetrock. Okay.
Is wallboard the same thing as drywall?
Yes. So silver, golds, and jewelry, other metals, or in electronic equipment for different reasons. Lead's using this word solder here. That word is solder. That is the like metal glue that holds together. Like the stool that Elizabeth's sitting on, there's like this metal glue. Do you want to hold your chair up for everybody?
I can.
Okay, go for it, Elizabeth. If you can pick up other girls, you can pick up a chair. See the circle is kind of glued together to the legs. That's solder that's there. Fun times. I just like to, people don't know what that word is, and it looks like solder, and then I'm like, no, don't be that kid. So anyway, tungsten's in light bulbs, salt is in food, the end. So there's more than 10 to choose from. So that knocks out number 6 for us. Y'all need a couple, yeah, I see people writing, so I'll give you a second. If you're done with this part, then cool. Great, good for you.
Tantalum.
Tantalum is that coltan that I was just talking about. That's part of the coltan. As far as what it looks like later on the PowerPoint, it'll kind of show you. It's this kind of little gray metal looking stuff. It's not real shiny like if you think about aluminum or something, but it's kind of a dull ore that you have to refine down. Minerals are fun. So there's that. Sinks and batteries. Oh, writing feverishly. You already did this yesterday, then good job. Okay, moving on. So mining is extraction of a resource from non-renewable. It's usually non-renewable. This little picture here is kind of depressing. It shows you how many pounds or ounces or whatever of different resources the average American will use in their lifetime. So over your lifetime, you will use half a ton, or excuse me, not half a ton, that's a half of a billion. So 500, no, that's 500,000. Half of a billion. There we go. I'm good at math. I'm just sleep deprived. So you'll use 500,000 pounds of coal, 978 pounds of copper, 73,000 gallons of petroleum. That's kind of crazy. So yeah, That's what you need over the course of your life. So most of these metals, they're actually, you cannot go out and dig a hole and find aluminum. That's not, the first and second groups on the periodic table, lithium, sodium, potassium, magnesium, calcium, and then also things like aluminum, boron, those things aren't found in isolation in nature. You get them out of an ore, then you refine it and smelt it, and then you can get the metals out. So the ore is the rock where you're going to find the minerals, but it's not actually the metal itself. So there's the coltan ore. So the tantalum that you're talking about, that's that part of the word. Okay. So, you know, the capacitor, that's running the electrical wiring and stuff like your phone. And always weigh your mixed metals. Tailings. So, okay, you guys, when you were mining yesterday, you had your cookie and you broke it apart and then you kind of scooched the crumbs off to the side. Did that happen? If you had crumbs. So the kind of leftover gang, the waste rock, that when you pile it up to the side when you're done, those are called mine tailings. Okay, so wastewater is stored in surface impoundment. So the wastewater is stored in these little ponds called surface impoundments. The leftover rocks and minerals that are not needed, those are piled up in what's called tailings. And so here's a surface impoundment. And so the tailings, it looks like they have been piled here, and then the impoundment is here. And you can see that erosion in this area is just rampant because they've removed all the vegetation.
So is that just runoff water?
Yes. Yeah, so like let's say that I have an open pit mine, a big old hole in the ground, I'm mining stuff out. If it rains and it's washing over this uncovered rock that's been crushed or whatever, it's definitely going to pick up traces of the minerals, and that could be bad or good. And so they have to have like a drainage pond and not let that run into the other surface streams and rivers. So we can also mine stuff for fuel. On the AP exam, they may have a world map like this. All this is cute and everything, but the answer is Africa. Like most of our precious metals, diamonds, minerals, things like coltan, and they all are coming from South Africa. We do have things like copper, zinc, and things in the United States, but like if you're given choices, the answer is probably Africa. And I've seen that question before. So anyway, lots of money comes from this, but also is environmentally damaging. If you go ahead and look on number 7, list and describe 3 types of surface deposit mining. I didn't give you a lot of room on that. I do apologize, but this is pretty important. So strip mining, let me show you what it looks like. I like to show people what things look like first. This is what strip mining looks like. You have, I'm wanting this coal right here. These coal seams, and notice how they're running parallel to the ground. So I can just, this is called overburden, this right here, that's called overburden. It's the rock and soil that's in the way of the coal seam. And so you can just take and strip off the layers of overburden and get to your coal seam and then scoop it up and then, you know, make lots of money. So that's what surface strip mining looks like. It's a very popular way of getting coal, oil sands, sand, gravel. It's environmentally damaging because you're stripping off the whole layer of forest, whatever it was there before. So you need to write this one down for number 7. This is the first kind, first way. Okay, so they're just, like I said, shallow horizontal deposits. This only works for when the ore or the coal is pretty close to the surface. If it's deeper than that, this is not going to work. You don't have to write all this down, just this part. Shallow mining, horizontal deposit kind of thing. All right, so again, that's what that looks like. On number 9, assume your reclamation efforts were negligible and resulted in acid mine drainage. Describe the effects of acid mine drainage. So when you mine coal especially, but other rocks as well, there's going to be sulfur in the rocks. That's just part of the Earth's crust. Sulfur, when it combines with oxygen and water, makes sulfuric acid. Okay, sulfuric acid is going to run into water bodies and lower the pH beyond the range of tolerance of aquatic organisms. So let's kind of get that down a little bit. So acid mine drainage happens when sulfide minerals or an exposed rock forms sulfuric acid, and that happens when you mix water and oxygen, then flow into waterways, and this is the ticket. Lowers pH below range of tolerance. And that's not really a proper noun, so. Range of tolerance for aquatic organisms. Aquatic life, that's faster way to write it. That range of tolerance is, like I said, and I'll keep saying it, I don't care that I already said it 3 times, I keep saying it. It's so important because you get on there and you're like, oh, I don't know what acids do to fish. I don't know what too much phosphorus does to a plant. Well, I don't either. It's beyond the range of tolerance. Okay. I'm not a biologist, and they don't expect you to be either. So you just say that and you're good. And now if that's wrong for me to say it, that's fine. But my test scores are in your test scores will be fine if you just do this. That's how that works. Coal, like I said, is pretty rich in sulfur, so it's pretty bad about that. That's what acid mine drainage looks like. And the red, it sometimes will be yellow or orange. As the acid reacts with iron, it will oxidize the iron, and so it basically rusts it, and that's the color that you get. Now I know all about that, and I can explain oxidation and reduction to you all day, but don't need to know that. Anyway, subsurface mining. I don't want you to write down on number 8. I don't really want you to do the 3 kinds of subsurface mining. The biggest thing about subsurface mine is that it's below, or mining, is that it's below the surface, obviously. But this is what you need to know about it. It is the most dangerous form of mining for the workers. You have these issues with dynamite blasts and collapsed tunnels, toxic fumes. Coal dust can lead to what's called black lung disease. This is number, where it says subsurface mining. It says 7, 8. Do you see it?
This is like what you think of mine's like.
Number 8. List and describe 3 types of subsurface mining. You don't need to have all 3 types of subsurface mining. What they're more concerned about on the AP exam is that, of course, you need to know what it is. Mines that access deep pockets of a mineral through shafts and tunnels. But instead of doing 3 times, I think it's more important for you to know the health effects. That's what they're going to be looking for on the AP exam. So, what ends up happening, people down working in the tunnels, you can have gas explosions, and that can be deadly. Also, you can have, parts of it collapse. And then black lung disease is, coal workers get that because they're underground. And they're mandated to wear masks, but it's very hot and it's like uncomfortable, so they won't wear them. And then all this kind of little fine particles of coal over years and years and years of working there will get into their lungs, and it will. It's called black lung disease, and it cuts down on your lung function, and it can kill you. So there you go.
Mary?
What happened?
This is like Mary Poppins.
Mary Poppins?
Yeah, where they're all covered in like black stuff.
Oh.
That's from Chimneys.
Well, that's from Burning Coal, probably, if it's Mary Poppins. I've never seen Mary Poppins.
What? Why?
Is it good?
Yeah, it's cute. Like,
Colby said no. Colby's shaking his head no. He said no. I'm good. Alright, so this is what subsurface mining looks like. So strip mining was for stuff that was really close to the surface. right? Subsurface mining is where the deposits are much lower under the ground. Now look, if I have some forest over here and I got a mountain and then I got a stream, they're not going to be disrupted by this. So as far as habitat fragmentation, this is the way to go. But if you're this guy, right, if you're this guy and then all this falls in, that's no good. So as far as the health of the workers, it's much more dangerous. But for the ecosystem and erosion and water pollution, this is better. Open pit mining is crazy looking. That's what that looks like. And you can see, like, that's a giant dump truck, like the size of your house right there. Yeah. So this is, I think this is a copper mine in Colorado or something. But that's open pit mining. So this is another kind of surface mining. So this is on number 7. Open pit mining, huge pits, massive amounts of tailings, the waste rock. And they're evenly distributed. So, you know, they're not at the surface. They're not way down deep. They're everywhere. So you just dig a hole and you keep digging a hole as deep as it'll go until you're not on the deposit anymore. These are crazy. Copper, iron, gold, diamonds, some coal. So the tailings that you get from this are enormous. I mean, you dug a hole like the size of, you know, the Astrodome, or probably several Astrodomes. So where are you going to pile that up? Somewhere, and then the tailings are going to be problematic. And then the last one we'll do placer mining. Placer mining. This is where, okay, have you seen this before? Have you done this before? Have you been this person? Well, you probably didn't use like a leaf or that is. Actually, that's probably the bark of a big tree. That's what that is. But this is the coltan miners in the Congo. They actually, instead of going to school and like complaining about homework, this is what they do all day because they're forced to by like soldiers. Good times. But anyway, so this is what coltan mining looks like. But also gold mining works the same way. That's, like I said, placer mining. So placer mining is where you're using running water, and the lighter materials come to the top, and the heavier ones sink to the bottom. Gold mining is very normal for this. You're going to disturb the stream banks. And did I tell you guys about riparian areas, riparian things? This is stream banks. I told you to go down to the bottom of a stream and you bust your butt on the stream bank trying to hold on to every branch possible. That area is the riparian stream bank, this riparian border. Have I told you that word before, riparian? It's because we haven't studied water. We're starting in on Friday. But if you see that word, that's how I'm out. Anyway, so yeah, it's going to disturb the area. It's going to cause erosion. That's what that looks like. Mountaintop removal, we already have 3 types of surface mining, but mountaintop removal is literally where you blow the top off of a mountain. So, like you'll have this strip of coal seam here. That's a giant dump truck. These dump trucks are like the size of houses. They are insane. But they just blew the top off the mountain. Just, you know, whatever, it's in the way. So, it's pretty scary. Sure, people try not to do as much of that anymore. Reclamation, that's where it's, I don't like the fact that the word restoration is popping up, and that's okay. It is a type of restoration. You're doing something, but in your mind, you have to know, it's like the difference between the word conservation and preservation. They sound the same, they're kind of the same, but they're not the same. Reclamation is where you're reclaiming the land for another purpose, but you're not going to put it back the way it was. That's restoration, okay? So, don't worry about it too much. But on number 3, explain why legislation that requires land to be restored after mining makes it more expensive, because you have to do this. You have to remove the structures that you used during mining, whatever it was. If you had some facilities in place, you have to take those down. You're going to have to replace the overburden, that was the waste rock and all that, and then you're going to have to replant the vegetation. So that costs money. The end. Pretty straightforward, right? So that takes care of number 3 for you. I think I told First period, something I didn't tell you guys. I skipped it. Can I go back? Pretty important. It was about tailings. Oh, there it is. The acid mine drainage from the tailings, sulfuric acid was in what she wrote down. You don't have to write this down, but cyanide is used for gold extraction. It helps to get the gold out of the rocks so you can find the gold and separate it. So in the Amazon, the AP people, I think they threw this on the test last year, and I wanted to mention it because you never know, right? But in the Amazon, they're starting to gold mine, so they'll get the little pans and the things on the river, and they're using cyanide because it's not illegal there. Well, cyanide is a poison, and it also makes an acid, makes hydrocyanic acid. But anyway, they're on the banks of the Amazon, and they're using cyanide to separate out gold, and then they'll let the cyanide run into the river. So it just kills the fish. The cyanide is out of the range of their tolerance. No, just kidding. No, it's a legitimate poison, so it's a neurotoxin, I believe. But anyway, so that's a thing. Not just sulfur that we have to worry about. Cyanide makes an acid too, but it's a poison. I just wanted to tell you that because I told them. You never know what's on there. So here is on number 4. Scratch out the words how and the, and I told you that yesterday. So describe the Surface Mining Control and Reclamation Act. So the thing is, for about 100 years, and I'm not exaggerating, for about 100 years on public land, mining companies would go out and mine, and they would have these open pits, and they would just leave them because a lot of times the companies would go bankrupt. And who was going to clean that up? Who's going to pay for that, right? So, anyway, in 1977, after about 100 years of that mess, the United States passed the Surface Mining Control and Reclamation Act. And so companies have to post bonds. That means they got to put up money first and put the money in a safe place, controlled by the government. They have to put up money first to restore the land. To reclaim land after they're done. So in case they go bankrupt, there's money sitting there to clean the mess up. Okay, so they put the money up first. So that's kind of nice, right? Other nations like the Congo don't have any regulations, so it's cheaper just to outsource to other countries. The more environmental legislation the United States makes, the better our quality of life, but it ensures the lessening quality of life for other people because we externalize this cost because we're not willing to pay more. All right, so that's number 4. Number 5, I'll let you do in a second by yourself. This is what reclamation looks like. This was probably a forest, and so they're replanting some trees, all of the same kind, and they're planting some grass, but it's not going to be the same thing that was. A lot of times they'll take places like forests and wetlands, and they'll just replace them with grasses. They have to prevent erosion, but it doesn't really have to be exactly the same as it was. So this is what you need to write on the back of your PowerPoint. This is on one of your test questions. So you got to think back to the late 1800s. The Civil War ended in 1865, right? And so that kind of conflict required quite a bit of metals. And so as we had this whole out westward expansion, manifest destiny thing happening, we kind of thought, we have a lot of resources, we need to exploit them. So on purpose, just like the Homestead Act, really, we encouraged, the Homestead Act was for developing land and you had to improve it, you got the land free and all that. Did you take history, so I think? Okay. Anyway, so the General Mining Act of 1872 encouraged mining. It encouraged it through any citizen or company that was willing could stake a claim on a public land open for mining for $5 an acre. $5 an acre. And after you did a little mining, you got to keep the land. That's a pretty sweet deal. This was in place for over 100 years, and they didn't raise the prices. Because once it was enacted, of course, the mineral companies weren't really willing to let go of this. This is pretty cool. Now this is messed up. Once a person owned the land, that land could be developed for any reason having nothing to do with mining. And there was a case where near like Telluride in Colorado, where super expensive ski slopes and ski resorts are there, this company actually opened a resort on land that was public land that had been claimed through the General Mining Act of 1872, and made this really fancy resort and made tons of money. So, anyway, the issue in the test is that it was very controversial because you didn't actually, even after the company got the land for $5 an acre, they didn't have to pay any royalties, which is where they have to pay, like if you make $1 million, you might have to pay 3% or 5% or 1%. But they didn't even have to pay royalties. So basically, they got the land and they got to keep all the money for free. Now, it's easy for us to sit here and say, oh, that's so bad. Why are people taking our public land and mining on it? But, you know, if we want to compete with other countries where they're using slave labor and they're using forced labor and they're financing wars where they have no environmental regulations, if we want to compete with those prices and keep children out of slavery, the stuff here would have to be free because we actually have workers' rights, we have insurance, and people have to get paid. So, I mean, we could argue against this, but then I could also argue for it because this is the only way to actually be able to take minerals from the United States and do anything with them. So it's pretty interesting, right? Environmental science is very multifaceted. And you got to be able to argue both sides of it. And so I try to do that. Yeah. So, yeah. Yeah. It provides essential products for domestic industry. I think we're good. Oh, yeah. Recycling is definitely way more energy efficient than mining it out. Like recycled aluminum. Aluminum comes from an ore. I'm gonna spell it, not because you need to write it, but if you want to, you can. But I'm gonna spell it because people don't know what I'm saying. So aluminum comes from bauxite. That's a U right there. And it's only like 10% aluminum. And so, you know, when you drink that can of Coke and it's, you know, government subsidized corn and acid and water, tap water from God only knows where, and it's in an aluminum can, that aluminum can is 90% crap, and they had to refine that 10% aluminum down, and they had to mine out the land, and that caused habitat destruction, and then how much fossil fuels went into doing that just so you could drink Coke. So, anyway, I think that's pretty interesting. But if you recycle the can, I mean, recycled aluminum has huge demand in the market because it is so energy dependent to make it, but 20 times less energy to recycle a can than make a new one. But that's all. I think I hit all the questions except for maybe number 5, right? So let me take a little break. You take a little break from listening to me. You do number 5, and then we're going to start the PowerPoint that you got on the way in the door. Hey. All right, so this first chapter is trees, trees, and more trees. That's the name of it. So this guy's looking at paper to make sure it's not screwed up. That's a very interesting job. I like how he has safety goggles. He's taking it seriously. On the back of your textbook, there's actually an eco label. If you have a paperback book, see how everybody has a paperback book with them? Look, there's an eco label for the forestry. Nobody's gonna get it out. I'm gonna hold it up. Dang, he's our man. If you don't have a book. See, look, right here. The FSE. See? See it? You got an eco label on your textbook. Do you have an eco label on any other textbook? That's why it costs so much. Yay! So the Forest Stewardship Council just certified the sources that the book was made out of and said that they were, you know, every step of the manufacturing process met certain standards. And then it was, I'm going to use the word farm because where we grow trees, that's a farm. It's not a functional forest. That's not the same thing. So what a forest is that. There are different kinds of forests. Yep. That's what they look like. All right, so just eyeballing this picture of the world here, what percentage of the earth is covered in forest, you think?
50. 35.
30 is the answer. You need to know that for your test. What percentage of the Earth's dry surface is covered in forest? 30. Write it down. That definitely looks like a third. I can see why.
What?
Forest. 30% forest is 30. Whatevs. It's 40% farmland, even though it's really 38. You know,
Who's rounded?
like maybe I should be more classy and like tell you exact numbers, but I really like know exactly what's on the AP exam, so I'm really gonna tell you those things. So, and that's why. I mean, if you just want to learn about the earth and recycle, I think I'm hitting those points too. But I'm kind of into that whole like test thing. So anyway, forests are really rich in biodiversity, and that's because they're structurally complex. So let me show you what I mean by that. If we look at this picture of the different layers and parts of a forest, you have the canopy, and that all the organisms that specialize in that's going to be different species. Then you have the subcanopy, the understory, the shrub layer, and the forest floor, and then you have the soil itself. And so you're going to have a lot of niches, and when you have a lot of niches, that means you're going to have a lot of different species to fill those niches. You have more biodiversity. Now in this picture, I know it doesn't look super important, but this like random tree here, that's this dead standing tree is called a snag, and you need to know that. And snags are really important for the ecosystem because even though they're a dead tree, it's going to be easy to carve a hole in the tree and make a nest. It's also going to provide a lot of food as bugs decay the tree. And then the fallen logs, that's a log that dies and falls over. See what I'm saying? I really can't make this any harder, right? So a fallen log is a tree that dies and falls over, and the thing about fallen logs are, if you go in and you remove those and you use them for whatever, making a table or paper or whatever, you're taking out nutrients that should be recycled and put back into the soil. So fallen logs, even though they're dead, they help with nutrient cycling and returning nutrients to the soil. Y'all good there? Alright, so these are the different parts of the forest, the canopy, subcanopy, all that. If we look at old growth versus young forests, old growth forests are going to have a greater biodiversity. There are some organisms whose niche is just living in very old trees, very large trees. They demand that the trees be of a certain age. And so if you have some people that are like, for every tree we cut down, we plant a new tree. Well, that's fine, unless you're an owl that only lives in old growth trees. Like, if you specialize in living in very large old trees, and somebody plants a baby tree, that ain't helping you, okay? So, cutting down a tree and planting a new one, that's not the same thing. Like, those people don't deserve a high five. Sorry. So, ecosystem services. On the AP exam, they're going to ask you, give an example of the ecosystem service, and they may say from the ocean, or from the atmosphere, or they may say from a forest, so better be able to answer that. So a forest provides you with stabilizing the soil and preventing erosion. Anytime that you have plant roots, you're going to prevent erosion. They're also going to slow runoff, prevent flooding, and purify water. Usually their soil isn't compacted, right? There's a lot of pore space in their soil, so they're going to be able to absorb extra water in case of a flood and prevent flooding. The roots are going to, this is pretty deep right here, literally. Roots are going to draw minerals from the subsurface, from the B and C horizons, and they're going to take those minerals and put it into the leaves. Well, then the leaves are going to fall off, and then those minerals are going to be returned to the topsoil. How cool is that? So, like I said, it's pretty deep. And then, of course, you have your social factors. Name a social benefit of the forest. It has cultural significance to Native Americans. Aesthetic value as far as being able to go and have recreational opportunities. So remember, social benefits are quality of life things, right? So having a forest to go and visit and camp in or whatever, that's socially beneficial. So here's all the ecosystem services. Trees do make oxygen. You could always go with that one. I think that's copping out though, you know, but whatever. They purify water. They filter pollution, like carbon dioxide, for example. They remove that from the air. We're going to get to that in a second. literally a second. I've been doing this too long. So carbon sequestration from trees is very important. So that helps to mitigate or lessen climate change. By the time we get to climate change, because we ain't even talked about it yet, by the time we get to climate change, you'll know everything about it. So carbon is stored in trees through whatever that's called, photosynthesis. There it goes. Sorry. And obviously, cutting down trees is going to worsen climate change for two reasons. The first reason is you don't have a tree making glucose and starch and cellulose, things that store carbon, so they're sequestering less. And then dead trees, when you cut a tree down and it dies, it's going to decompose and make CO2. The bacterial decomposers, they are going to take up oxygen, just like when we talk about algae dying and eutrophication and all that. When bacteria decompose trees, or if you burn the trees, you're going to make CO2. So when you kill a tree or cut a tree down, when trees die, it makes climate change worse. So anyway, there you go. Preserving forests keeps carbon out of the atmosphere. Also, forests provide economically valuable resources. So on the social topic there, you can highlight this if you want to. Oh, here you go. We had talked about biodiversity and the value of medicine and research. Most of those are coming from forest plants. Also, food. Animals, plants, and mushrooms for food. And then wood for fuel and trees and shelter and stuff. So there's that. Most commercial timber is extracted in Canada and Russia from the boreal forests, rainforests, like in Brazil and Indonesia, and then pine plantations. Oh, sorry. In the United States, when you get paper, it's probably come from a pine tree in South Georgia. That's where it's come from. Have you ever driven to like Savannah? And then there's like trees, but they're in like straight rows. Yeah, that's a plantation. And like I said, it gets on people's nerves. It's on my nerves when people say, "Oh, for every tree we cut down, we plant another one." Do you give like a corn farmer a high five for planting another corn plant? Do people be like, "Good job, corn farmer, way to plant another corn plant"? No. So when somebody owns a pine plantation and they cut down a tree and they plant another one, that's their crop. That's their harvest. So when people talk to me and they see me printing out PowerPoints for AP Environmental Science, they're like, "You're cutting down all the trees." Homie, I'm not cutting down all the trees. I'm basically doing the same thing as eating some broccoli. Like, this is a crop. Trees are a crop. And these forests are not functional forests. They're all they're even age tree stands. They're a plantation. And so you should always try to conserve resources if at all possible. Like, it doesn't matter if it's renewable or corn or broccoli or trees. Like, you should try to prevent it. But I mean, I feel like I have to give you some notes, right? But let me know if you decide you don't want it anymore. I'll stop. But so anyway, there's that. Nope, I'm not doing it. Nope, not doing it. I'm not gonna tell you what deforestation means. Primary forests. There's so many things in this class that are called like primary and secondary. Like, I know primary and secondary succession. This doesn't have anything to do with that. Okay, like, it just means first and second. Like, those words are the words that they're using because they're first and second. So primary forest is like my old growth forest. Second growth forest is a new, or secondary forest is a newer forest. So I'm gonna put an old growth right here. Also called the old growth forest, primary forest. So those primary forests are going to be more they're going to have a higher biodiversity because you're going to have the older trees. So, yay! This is the saddest thing you're going to see today. Maybe not. I don't know. That Colton thing's pretty depressing to me. So this is 1620, and this is the areas of uncut forest. Just let that soak in for a minute. Thank you for taking care of the United States for us Native Americans. You've kept it all nice and pretty, just waiting for us. So this is like today. Moment of silence, right? I wonder if this like is that mountain where that one salamander lives. You know what I'm talking about? The one in West Virginia where there's You know what I'm talking about?
That's
Yeah.
my power plant forever ago.
Yeah. There's like a salamander who lives on one mountain in West Virginia, and I think that's it. That's not funny. I'm sorry. And you know the funny thing is, like, here's the Appalachians, and here's the Rockies, and here's the Sierra Nevada. Like, those green patches are just there because we were like, you know what, screw it. I can't get the oxen up the mountain. We'll just leave those. You know, that wasn't because we were trying to be nice. So all the forests that we have, or most of the forests we have in the United States right now, is it's secondary forests. I mean, it's there, but it's not like it was, unfortunately. So anyway, there's where we grow our corn and soy for the Doritos. You know, that's where that is. But the rest of it was forest. It was beautiful, lovely forest. Sorry about that. So uncut tropical forests still remain. Those primary forests, the worldwide, where they're found now is mostly in developing countries. Developed countries have already, well, developed all their forests. So anyway, most those primary forests are in developing countries, but technology, you know, technology, we're not using technology to save the earth. We're using technology to, like, save money and mess stuff up. So we can exploit these forests faster. Brazil actually had the highest rate of deforestation of any country, and, you know, we're like, we should save the rainforest. Brazil, like, their own government subsidized clearing the rainforest. And who are we? Y'all just saw that map I showed you, right? Like, who are we to say, don't cut the rainforest down? We need it. Oh, do we? Is that what we need? Trees? You sure? So, you know, they subsidized the clearing of forests so that they would have to import less beef and import less grain, and they could actually export those things. And that worked. But they did establish a forest code, which kind of slowed down the rate of deforestation. But there for a while, they were encouraging it because subsidies give money away to things that you want to. Yes.
Well, are they like doing it better than we did?
As far as how they're doing now, yeah. I mean, the rate of deforestation is still pretty high. But as far as the rate that we had before, I don't know. As far as the time. I bet the rate in the 1970s and 80s was probably higher than our rate, just because they have technology now that we didn't have, you know, early 1900s. This is on the test. It's right there, that one. Developing countries, they're often so desperate for economic development, they don't have any regulations on this. Pretty straightforward. So here's a little slice or picture of Brazil. I know, right? Magic. So anyway, this is an area in Brazil in 1975, and this is the same area in 2001. So that's 26 years. That's pretty quick turnover for that area to be deforested. So like I said, it's probably at a faster rate now, to be honest. So this is, we talked about swidden agriculture, where you would slash and burn an area, you know, graze cattle and raise crops on it for a while, and then move on to another little patch. That can be sustainable on a very small level if you do it slowly, but that's not how that's working. And so if we look at areas where deforestation and actually reforestation are happening, the green means that you have a net increase in trees. And so if we look at North America, United States, Canada up here, actually increase in trees. So the United States is not, we're not cutting down all of our trees. That's not what we should be worried about right now. South America, 8.7% loss, so that's an issue. Africa, 10% loss. So the developing countries where you are lacking those regulations, they're seeing the highest rate of deforestation, and also they have the fastest population growth as well. Asia, you actually have a gain in trees there. A lot of that's due to Russia, because Russia, they had a pretty bad economic downturn after the Cold War, so they kind of chilled it out a little bit. And then forest is getting regrown in Europe, so that's kind of cool. So there's that. A concession is where you pay a government, in this case. So a multinational company is going to come into a developing country and say, hey, I'm going to give you some money, and then I'm just going to, like, take these trees right here. Is that cool? Yeah, okay, here's some money. That money never trickles down to, like, the indigenous people living in the forest. That money doesn't get there. That just usually stays in the pockets of the government officials. It does make temporary job. Whoops. Well, hey, whatever. Magic. I want the whole thing to light up. That was cool. There. I like this. Oh, whatever. Anyway, so there's going to be temporary jobs and a little bit of money, but as soon as that resource is exploited, it's not going to be replanted and taken care of because these companies have no real ownership of the land. So kind of a tragedy, the common sort of situation. Really interesting. We talked about it last period. Palm oil, palm fruit oil. So you guys know about trans fat, right? And trans fat's bad. And so we're going to replace it. Trans fat was basically partially hydrogenated soybean oil. Most of that, like Crisco in a can like your granny uses, you know, do you have a granny? Yeah, yes. I can make biscuits out of that. Like, I know how to do that. That's what I did like 3 times a day when I was growing up. I can cook dumplings. I can make biscuits. I got it. Like, it's, yes, certified right here. I know how to fry bologna to go with the biscuits. This is me. I just moved on up at the trade part, but I can totally do all that stuff. Anyway, so we got rid of trans fat like shortening, and what we did, that stuff was used in like Little Debbie's, peanut butter, any like bakery item. And what we did, we replaced that shortening with palm oil. And so palm oil doesn't contain any trans fats, but it contains a lot of the same chemical properties where it can make your stuff crispy and have a good shelf life, and it can make your peanut butter not separate. You know what I'm talking about with that peanut butter, though. You ever buy that natural peanut butter and then you regret it? Like, is this really worth it? I don't want that much. And then you're like stabbing it, trying to get it mixed up. If you've never bought a jar of natural peanut butter, you haven't. Well, you're smarter than me. That stuff is, I'm like, I need some trans fat in here because the trans fat keeps it a solid at room temperature. So that's what that means, by the way. I mean, I can go into the chemistry with you, but that's what's happening. Anyway, palm oil was used for stuff as a replacement for trans fats. Also used for soaps and cosmetics and stuff. But here, what they're doing, this is on the island of Borneo in Indonesia. This is, you know, Indonesia has tropical rainforests. It's at the equator. But they've taken this area and they have cut down the rainforest and they have planted these palm oil trees. And so let me kind of, and the thing about it is, this island, that's where orangutans live. And so these orangutans, where the palm oil's in there, I actually looked up the eco-label last period for them. So when you buy stuff with palm oil in it, it has this eco-label if you know that, you know, Borneo is not getting deforested. And actually the Girl Scouts, I don't know if you're about to ask me, I hope you're asking me about Girl Scouts. But the Girl Scout cookies actually have this eco-label after everybody pitched a fit about the palm oil and Girl Scout cookies. Yes, ma'am?
Why was there arrangements in a wheelbarrow?
I don't know. We'll go back to those pictures in a second. Yes, sir?
Like the peanut butter thing, so like my sister used to have a lot of almond butter, and it used to be like
Yes. Yes.
and stuff, and like,
Yes.
is that what you're talking about?
Yes, and so, like, for example, Justin's, you ever seen, like, Justin's Nut Butter Company? Their stuff is legit. Anyway, they have, their eco-label on their stuff actually has a little orangutan on it. Let me go back. I had that pulled up. Let's see. There it is. Orangutan-friendly palm oil. Where was one in the wheelbarrow? Oh. Let's see. Bye, Forrest. You were nice while we knew you. Aww. That's kind of sad. OneGreenPlanet.org. That sounds like a tree hugger site if I ever heard one. Orangutans don't understand why we need palm oil. Aww. I told you this was like a thing. There's a whole website apparently. Well, let's look at it. It'll be fun.
Animal monster. Food
What?
Monster.
Buzz Monster.
Oh, look at it.
Aww.
Why would you
Palm oil can be found in 50% of consumer goods, but there's a high likelihood you've never heard of palm oil. Yay. The demand for palm oil has increased exponentially because it's a cheaper alternative to other vegetable oil. Yay.
It doesn't even look like the palm thing. Like the palm tree.
You know, Doritos really does have soybean oil in it. Sorry. I know that's the thing. It does. I've read the ingredients. Aww. Aww.
He looks so tubby.
That's a cute one. Not even protected forests in Indonesia are safe. 52,000 hectares of land in the national park have been converted to plantations for palm oil. Ooh, I wonder what that goes to. You want to see? I just do this, and I just depress myself. I hope it's okay. I'm sure it's totally fine. Are you eating orangutans into extinction? That's depressing.
Oh, wow.
Orangutans are cute.
I used to watch Orangutan Island when I was little.
Oh, wow. And that's a picture of what I was showing you in the PowerPoint. That's not a functional forest anymore, obviously. Oh, wow. So there's the palm plantation, and there's the actual habitat. Oh, wow. Indonesia is home to 3% of the world's forests, yet the rampant deforestation of the region accounts for 1/3 of the global carbon emissions. Oh, okay. Okay, I knew that. Oh, wow. Oh, so it was illegally done. Oh, okay. Oh, they're pests, and they found them. Okay, so that's sad. Just thought I'd show you a little bit about the orangutans and palm oil, because we were talking about forests and stuff. Yeah, so there you go. That's more interesting than the slide, I think. I mean, as far as like seeing what happens. Okay, back to this. Yay. So that's what happens when, you know, a company goes in and makes a concession and then has the right to extract the resource. A conservation concession is kind of the opposite. A lot of times this will happen with like the Nature Conservancy. They're a NGO, a non-governmental interest or organization, and so they'll come in and they'll give money and then set some land to the side for preservation, and then also things like land trusts. They'll buy land and put it to the side and say, you know, we own this land now, and you know, we're not going to make palm oil anymore or whatever. So forestry and resource management. When we look at this. This is the same thing that we talked about when we talked about goldfish crackers. You want to harvest at half the carrying capacity, and so this is called maximum sustainable yield. And so when we're harvesting trees, we don't want to harvest them. We don't want to harvest them when they're growing slow. We want to harvest them when they're growing the fastest, because as soon as they start slowing down on their growth, that stays wasted on your harvest. So you don't want to harvest old tall trees that are growing just a couple inches a year. You want to harvest them right before they start slowing down, so at their fastest. I know that seems weird, but if you think about it, look at the slope of the line. It starts to slow down here and slow down here and slow down. So the rate of growth is slower. So you want to harvest them right before they start slowing down on the growth. So anyway, this is, like I said, called maximize sustained yield, or maximum sustainable yield. And so you want to harvest trees. Or anything. This also works for, you know, fish populations. But you want to harvest them at intermediate size and, you know, about half the carrying capacity. Harvesting timber like this, the only thing about it is, if you do that, you're never going to have really old, really big trees. Ecosystem-based management. Okay, so what the National Forest is. You need to know that the National Forest was set to the side for public land use, to grow trees, to harvest trees in case of a timber famine. We were afraid of a timber famine. We were afraid we were going to run out of trees because we had already exploited the eastern seaboard. So we were afraid we were going to cut down trees, blah, blah. And so we set aside the National Forest. Also to protect watersheds, but the National Forest System has a multiple use approach. It's for many things. You can camp in a national forest. You can use it for recreation and stuff, but its purpose was to make sure that we had timber available. It's not a park in that sense, okay? The national parks are different. So management does include logging and replanting trees. Great is good for the most in the long run. Yeah. 1905. Good times. Ooh, do you remember the guy that helped to start this? His first name was Gifford. Yeah, do you remember him? Yeah, I remember him. So that was conservation, like he was a conservationist, right? And so they're there to use. All right, look at these colors on this map. And what we're looking at here, this is a map showing you different kinds of public lands. So these are, all the colored places are federally owned public lands. That means they're technically, a little bit of them are yours, right? These are public lands. What's the biggest color on here? Purple. Purple. The purple is BLM land, Bureau of Land Management. You need to know that. That's on the test. The largest single landholder in the United States, public landholder, is the Bureau of Land Management. I don't know if it's actually written on the PowerPoint somewhere, but if it's not, there you go. Okay. So it's kind of funny. I mean, you can really read this. Basically, what ended up happening, the people that live over here that are in charge of the government, we had our, you can just see us like going west, westward expansion, westward expansion, westward expansion. And then this is about where westward expansion got to in the early 1900s, which was at the time, we had Roosevelt in office, right? And he had some friends that liked to hang out here and hunt and stuff, and they took him out there and he hunted and hung out. And then we're like, you know what, we kind of destroyed, I don't know, from here over. So I guess we'll start protecting some land. That's messed up, but you can see, I mean, our closest national park, I mean, there's the Smoky Mountain one. It's real small, and it's right there. But look, here is the Everglades. I mean, alligators live there, so whatever. I guess we won't mess with that. Nobody developed there. The alligators will get them. Then you have some mountainous areas that were forested that didn't get cleared because mountains were there. It's too much of a pain in the butt. But, you know, it's about right here. That's where we had expanded to before we started protecting land, which is really kind of interesting and also kind of sad. The brown parts, the National Park Service, they're mostly found out west. Quite a bit of that in Alaska. There's Volcano National Park. I went there. It was great. I saw a volcano and I ate dinner beside it. I love it. Not on topic. Yellowstone is huge. That's pretty cool.
What about the Great Lakes? Are they protected by the fish, or is that just?
The Great Lakes has some national forest up here.
Oh, but I was at like Fish and Wildlife Service if they were protected by that because it's blue.
So I think that's just because they're a lake.
Okay.
Yeah, no, that's a different color blue. It's a darker color blue. So sorry, no. There's a tiny spot right here. See it right there? Just a little speck. So that's pretty interesting, I think. So the green is the Indian Affairs land. That's the marginal land that we gave to the people that used to live here, and then we took their stuff and kicked them out, and then we took everything. Okay, so most U.S. logging actually happens on private land today. What is my problem? And those private landowners are going to replant a tree for everyone they cut down because that's how you make money and that's how you make paper. Like I said, they're farmers. So private companies, they tend to do clear cutting. The Forest Service does manage and plan the selling of lumber from the national forest. So you as a taxpayer actually help to subsidize this, and you do so by helping to fund the roads for the forestry companies to get in and out of the national forest. Okay. And you can see there's a net annual growth. The regrowth of forests is faster than the removal in the United States. So I mean, like I said, this is not the major issue for us as a country. So there's two different kinds of ages of forest, and we did this when we looked at the harvesting methods. So you have even age and uneven age. Even age tree stands are more like a crop or a plantation than a real forest. I already said that. Uneven age tree stands, that's more where you have different ages. That's more characteristic of an actual forest. Not everything's going to be the same size planted in perfect rows in a real forest. And so this picture shows, I mean, like I said, if you've ever driven to South Georgia, you see this. They're all the same size. They're in straight rows, and that's a timber company. And this actually has nothing to do with what we're talking about right now, but this is super duper fire suppression. Check out how crowded that understory is, right? All the brush layer. Dude's driving by. You see the guy who's right here, throws a cigarette out the window. It looks pretty dry, and it's also very, I mean, that's a lot of fuel for fire. So it's going to climb up these ladder trees, crown fire, everything's dead. Just thought I'd throw that in there. Clear cutting is the most cost efficient, but it's also the greatest ecological impact. You're going to have an issue with soil erosion because you've removed all the vegetation. It's the most widely used harvesting method because it's cheaper. So that whole money thing, you know. That's what that looks like. Yep. These were what we looked at when we made the foldable. I don't feel like I need to highlight that right now. Anytime you remove vegetation, you could cause erosion and landslides. That's on the test. Landslides are from removing vegetation. Right there. You just want to write that down. Right, this guy. Okay. Were you feeling pretty good about all this when we did it last? Pretty straightforward. Multiple use. Here's some question on the test. So this is what forest land, national forest was supposed to be. It's multiple use. Timber production was the primary purpose to start with, and so forest lands can be used for recreation, habitat, minerals, grazing animals. All those things are allowed as long as you have a permit. And logging is allowed because that's what it was for. This is on the test. This little law right here. Whee! It mandated that every national forest have a plan for renewable resource management based on multiple uses, recreation, trees, recreation, I think I already said that, mining. Mining's kind of slowed down on national forest land, but, and then public input. So you may want to put that in your brain. The Forest Service helps to come up with those plans and manage them. For 100 years, the Forest Service actually suppressed fires on purpose because we had cut all the trees down, all the old growth trees, and we freaked out. So we were like, let's save all the trees that we saved, and we'll not let the fires destroy them, and it'll be great, it'll be good. But that actually makes fires, when they happen, a lot more destructive. Fire suppression leads to occasional catastrophic. Oh, this is where I stopped last period. I'll stop here. Yay, we made it.